right, if you're in DevOps, you already know the deal. The pressure is constantly on to build systems that are rock solid, secure, blazing fast, and can scale to the moon. But what happens when things grind to a halt, when latency spikes, or a service just vanishes? More often than not, the culprit is hiding in those invisible connections between all your systems. So today, we're going to make the invisible visible. You spend all your time building these amazing, scalable systems. But the real trick, and let's be honest, sometimes the biggest headache, is how do they actually talk to each other? So let's break down the essential networking concepts that can turn that headache into a smooth, seamless flow of data. I'm telling you, this isn't just another skill to check off a list. It's a genuine superpower. A deep understanding of networking is what separates a good DevOps engineer from a truly great one. It gives you the power to troubleshoot, to optimize, and to really secure the infrastructure that you own. So where do we even begin? Well, to understand any of it, we have to start with the fundamental rules of the road, the rulebook for all data traveling across the internet. And that means looking at two critical models: OSI and TCP/IP. First up is the OSI model. Now think of this as the grand theoretical blueprint. It breaks down the entire process of network communication into 7 distinct layers. It starts all the way down at the physical cables and works its way up to the actual application you're using. It's fantastic for pinpointing exactly where a problem might be happening. Okay, so that was the textbook version. This is where the rubber meets the road. While that 7-layer OSI model is the perfect blueprint, the TCP/IP model is what's actually running the internet today. It's way more practical. It basically condenses those 7 layers into a more streamlined 4-layer structure that we all use every single day. Now, within these models, data gets sent around using specific sets of rules, or protocols. And at the transport layer, you've got this really crucial choice to make. It's basically a face-off that pits reliability against pure raw speed. This is the battle of TCP versus UDP. Yeah, this is all about picking the right tool for the job. You've got TCP, the Transmission Control Protocol. Think of it as your super reliable, dependable workhorse. It makes a connection, it checks its work, and it guarantees that all your data arrives in the right order. Perfect for things like web pages or email. And then you have UDP, the User Datagram Protocol. It's the opposite. It's fire and forget. It's incredibly fast because it doesn't do all that checking, which makes it ideal for video calls or gaming, where a dropped packet here or there is no big deal. But speed is everything. All right, so we've got the rules and the protocols, but how does a packet of data actually navigate the globe? How does it get from a server in one country to a laptop halfway around the world? Well, that's the job of the Internet's global address system. It all starts with the IP address. Every single device connected to a network gets a unique one. The Internet Protocol uses this address, kind of like a digital postal service, to route your data packets through a maze of routers all over the world to make sure they find the most efficient path to exactly where they need to go. But in the real world, especially in the cloud, with something like an AWS VPC, you can't just have one giant chaotic pool of addresses. You need order, you need security, and that's exactly where subnetting comes in. It's the process of carving up your big network into smaller, more manageable, and more secure subnetworks, all by using something called CIDR notation. And this CIDR notation thing, it gives you some serious flexibility. For instance, a /17 block gives you a massive chunk of over 32,000 IP addresses. But maybe you need a smaller, more isolated network for a specific service. You could use a /28, which gives you just 16. Mastering this is absolutely key to designing cloud networks that are both efficient and cost-effective. So the IP address gets the data to the right server, the right building, right? But how does it find the right application inside that server? That's what ports are for. If the IP address is the street address of an apartment building, the ports are all the different apartment numbers inside. They're crucial for everything from firewall rules to how your containers talk to each other. And look, as a DevOps pro, there are a few port numbers you just have to know, like tattooed on your brain. Port 22? That's your secure gateway, SSH. Ports 80 and 443 are your bread and butter for web traffic. HTTP and the secure version, HTTPS. And you'll see common tools like Jenkins often hanging out on port 8080. Of course, none of us are walking around memorizing long strings of numbers for IP addresses. Thank goodness for DNS, right? It's literally the internet's phone book. It does that simple, critical job of translating a name we can remember, like website.com, into an IP address a computer can use. But modern DNS does even more, with services like AWS Route 53 using it for complex traffic balancing and caching. Now, with all this information flying back and forth, you've got to talk about security. That's where a VPN comes in. A virtual private network creates this private, encrypted tunnel right through the public internet. It's absolutely essential for doing things like securely accessing a remote server for maintenance without exposing any sensitive data to the open web. Okay, so we've got the theory down. That's great. But what do you do when an application is slow or a service is just down? You need tools. You need a go-to troubleshooting toolkit to figure out what's really happening under the hood. So let's run through the absolute must-haves in your networking toolkit. Each one of these gives you a different piece of the puzzle, and knowing which one to grab and when is what makes all the difference. First up, the classic, ping. This is your first question, always. It's the quickest way to answer the most fundamental question. Hey, are you even there? It just sends a tiny packet and waits for a hello back. Simple, but so essential. Okay, so ping works, but everything is painfully slow. Why? That's when you pull out traceroute. It's like getting a turn-by-turn map of your data's journey, showing you every single hop it takes between routers and how long each one took. If one of those hops is taking forever, you've just found your bottleneck. Want to know what a server is doing right now? Use Netstat. It gives you a live look at all the active network connections. If your service isn't responding, this command will tell you if it's even listening on the port you think it is. Think of Nmap as your network detective tool. You can scan an IP address or an entire network, and it'll report back with what machines are online, what doors or ports are open, and what services are running behind them. It's just invaluable for security audits and just mapping out your environment. Ever have one of those moments where you know a service is up but you just can't reach it? It's probably a DNS problem. Dig and NS lookup let you go straight to the source and ask the DNS servers directly. Hey, where are you really sending people who ask for this domain? It's crucial for hunting down misconfigurations. And finally, iPerf. This one brings us right back to where we started with TCP versus UDP. When you need to know the real-world performance of your network, not just the theoretical limit, iPerf is the tool that measures your actual bandwidth for both that reliable TCP traffic and that speedy UDP traffic. Look, getting a solid handle on these concepts and these tools, it's a total game changer. It'll make you a far more effective DevOps engineer. Because here's the thing, your network is talking. It's constantly sending signals about its health, its speed, and its security.